Hi everyone. So today we're taking a look at solving by using square roots. So a method of solving quadratic equation is using square roots. Times that you'd want to use square roots to solve quadratic equations are any time that you have a quadratic equation that there's no linear term. So if you take a look at our example right here, we have 2x squared minus 64 is equal to 0. Because there's no linear term, we don't have to factor this. We can move the constant term over and then isolate for our variable. Okay, so here you have some steps of how to solve by using square roots. Your first step is always to move the constant term to one side of the equation. So we have our variable on one side, the constant term on the other. Divide by the coefficient of the quadratic term, and then take the square root of both sides. Remember, don't forget the plus or minus sign, because there are going to be two solutions since we're dealing with quadratic functions or quadratic equations. And then perform any remaining operations. Now, step 4 you aren't really going to have to do until we get down to examples 5 and 6. For the most part, there's just a 3-step process to solve by using square roots. Okay, let's take a look at number 1. Now, for number 1, what you guys might notice is that this is actually a difference of perfect squares. So you can factor this if you'd like, or you can use square roots. Since today we're solving using square roots, I'm going to show you that first, and then I'll show you how to factor using difference of perfect squares. For the most part, anytime you see something like this, you're going to use square roots just because it might not be easily factorable. Okay, so to use square roots, my first step is to move the constant term over. So I'm going to add 16 to both sides. So I have x squared is equal to 16. Then I'm going to take the square root because I don't have a coefficient of x squared. And I get that x is equal to plus or minus square root of 16 is 4. Now just for this one, I want to show you the difference of perfect squares. So because we have x squared, this is going to be by factoring. So for this one, we have x squared minus 16 is equal to 0. X squared and 16 are both perfect squares. So we need two numbers that multiply to negative 16 and add to 0, which are going to be 4 and negative 4. So this would factor to be x plus 4 times x minus 4 is equal to 0. If we use the zero product property, we get x plus 4 equals 0, x minus 4 equals 0. And we get that x equals negative 4 and positive 4, or x equals plus or minus 4, like we got over here. Again, most of the time with an equation like this, you're going to be using square roots. I just wanted to review how to factor using difference perfect squares. Okay, let's take a look at number 2. So for number 2, looks a lot like number 1. The only difference is the constant term now is not a perfect square. So we definitely have to use solving by square roots. So the first thing we're going to do is add 12 to both sides. So we have x squared is equal to 12. Then we're going to take the square root of both sides. And we get x is equal to, remember, don't forget the plus or minus. And this is reviewing what you guys did yesterday with simplifying square roots. We have the square root of 12, which we have to break down. Now there's two ways to do this, either perfect squares or a factor tree. Now using perfect squares, we're looking for the largest perfect square that goes into 12, which would be 4. So another way to write this is the square root of 4 times the square root of 3. Square root of 4 we know is 2 times root 3. So we know the square root of 12 simplifies to 2 root 3. Now using a factor tree, we're trying to break 12 into the prime factorization. So we know 2 times 6. 6 is 2 times 3. And we're looking for pairs because we're dealing with square roots. So we have a pair of 2s. Remember, the pair goes on the outside. The number that's left over is on the inside. And we're only looking at the end of the branches. So that's going to simplify to 2 root 3. So your final answer is going to be x is equal to plus or minus 2 root 3. Now for the following examples, you only have to choose one of the methods for simplifying the square roots. I just wanted to review both for you. All right, let's take a look at number 3. So for number 3, again, first thing we're going to do, here, let me focus that for you guys. It looks like it's getting a little blurry. For number 3, first thing we're going to do is subtract 64 from both sides. So we have 2x squared is equal to negative 64. Now, our second step is to divide by the coefficient of the quadratic term. Up until this point, we haven't had a coefficient of the quadratic term. So here we're going to divide by 2. So we have x squared is equal to negative 32. So we'll take the square root. We get that x is equal to, remember, plus or minus. Now the square root of negative 32, a couple things to remember. When you have the square root of a negative, you're going to have to include I. Then we're going to take the square root of 32, which I know 16 goes into 32. It's the square root of 16 times square root of 2. Square root of 16 is 4 times root 2. So that means the square root of negative 32 simplifies to 4I root 2. Okay, now taking a look at number 4. Now for this one, the way that it's set up, because we're using square roots, our constant term is already on the right side, so we don't have to move that. We could divide by 3 to get x squared is equal to 20. Then we're going to take the square root of both sides. So we get x is equal to, again, don't forget the plus or minus. Let's simplify the square root of 20. So that's the square root of 4 times the square root of 5. Square root of 4 simplifies to 2 root 5. So we get that x is equal to plus or minus 2 root 5. Okay, so for numbers 5 and 6, these are a little bit different because there's a couple things going on inside the quadratic term. So the first thing we need to do is isolate that quadratic term. The way we're going to do that is the same as solving a linear equation. We're going to first add 5 to both sides. So we have 2 times x minus 3 squared is equal to 50. Divide both sides by 2. So we have x minus 3 squared is equal to 25. Now that we have our quadratic term by itself, we could take the square root. So we have x minus 3 is equal to plus or minus square root of 25 is 5. Add 3 to both sides. So we have x is equal to 3 plus or minus 5. Now, because we took the square root of a perfect square, we can actually find the exact solutions by simplifying this. If this wasn't a perfect square and you had a root in your answer, kind of like number 4, then you wouldn't have to plug these in. Let's simplify. So let's start with the minus. So 3 minus 5 gives us negative 2. And then 3 plus 5 gives us positive 8. Okay, and those are our two solutions. All right, for number 6, this is our final one. We're going to subtract 10 from both sides. So we get 5 times n plus 4 squared is equal to 140. I'm going to divide by 5 on both sides. That's going to give us n plus 4 squared is equal to 28. Take the square root of both sides. So we have n plus 4 is equal to plus or minus square root of 28. Let's simplify over here. I know 4 goes into 28, so root 4 times root 7. Square root of 4 simplifies to 2, root 7. Then to solve for n, we're going to subtract 4 from both sides. So we have n is equal to negative 4 plus or minus 2 root 7. Now for this one, because we have a root in our final answer, that's our final answer. We don't have to simplify that. Okay, so that's solving by using square roots. Please complete the assignment that's on Google Classroom. And feel free to reach out to one of us if you are having any difficulty or if you want us to check your work.